Everybody, we're getting ready to do pre-calculus math today. 5.2 part 3, lesson 5.2 part 3. So this is my email if you need materials, course materials. 5.2 part 3, verifying trigonometric identities. We got 24 points here on your classwork sheet. You got 2 points here on your notebook guide if you have one. Teachers, today we're going to go right into our lesson. Classwork page 1 part 3 here in examples 1 through 5, which you've already done. You've been verifying trigonometric identities by working with one side of the equation and converting it to the form given on the other side. On occasion it is practical to work with each side separately, keyword there, separately, to obtain one common form equivalent to both sides. So let's get into an example here, working with each side separately of verify the identity. So cotan squared theta over 1 plus cosecant theta equals 1 minus sine theta over sine theta. So we're going to work with each side here separately. Working with the left side here, you have cotan squared theta over 1 plus cosecant theta is the same thing here as cosecant squared theta minus 1. This equals that. And then 1 plus cosecant theta equals 1 plus cosecant theta, doesn't it? Yeah, it does. So we changed our numerator here by using a Pythagorean identity, working across here like that. And then so cosecant theta minus 1 times cosecant theta plus 1 here over 1 plus cosecant theta. So we're going to factor this into this here. These will cancel here. I mean, this becomes this down here on the right side here. And then we factor these out of your numerator. So when we simplify that expression, we get cosecant theta minus 1. Now simplifying the right side, we simplified our left side. Now we're going to simplify our right side. So now 1 minus sine theta over sine theta equals 1 over sine theta minus sine theta over sine theta. We're going to write as separate fractions here. Sine theta over sine theta, then 1 over sine theta. So when we do that, we have a reciprocal identity here, cosecant theta minus 1. This is cosecant here, and then this is 1 here, right? Sine theta divided by sine theta would be negative 1. So now we have cosecant theta minus 1. So the identity is verified because both sides are equal to cosecant theta 1. That's one way of doing it. A numerical solution, using a graphing utility to create a table that shows the values of y1 would equal cotan squared x over 1 plus cosecant x, and y2 would be 1 minus sine x over sine x. Now, if we put that into a graphing calculator for different values of x, here's your table here for y1, y2, and then we get identical values here at 1. So down here, the values y1, y2 appear to be identical. Do they not? These all appear to be identical here. So the equation appears to be an identity. Let's try one now. Let's go into our guided practice. And we're going to use a graphing calculator to check our result graphically. So we got tan cubed alpha minus 1 over tan alpha minus 1. That's the same thing as tan squared alpha plus tan alpha plus 1. We'll worry about this one later. Let's do this one up here now. So our guided practice, tan cubed alpha minus 1 over tan alpha 1 would be the same thing as tan alpha minus 1 multiplied by tan squared alpha plus tan alpha plus 1 over tan alpha minus 1. And then when these cancel out here, tan alpha minus 1, this will cancel out here. So this becomes tan squared alpha plus tan alpha plus 1. So this proves that these two are equal to the same thing. Now down here, do I do that? Oh, I do. It's your lucky day, students. So sine cubed beta plus cosine cubed beta over sine beta plus cosine beta equals 1 minus sine beta multiplied by cosine beta. So here we have sine beta plus cosine beta multiplied by sine squared beta minus sine beta cosine beta plus cosine squared beta over sine beta plus cosine beta. This becomes this down here, and then when we do some canceling here, we have equals 1 minus sine beta over cosine beta. So sine beta plus cosine beta, that would cancel out. See, sine beta plus cosine beta, this would cancel out here. And then sine squared beta minus sine beta cosine beta plus cosine squared beta. There's a Pythagorean identity here, and then that equals 1. This equals 1 here. And then so it's 1 minus sine beta cosine beta, which would be here. So sine squared beta plus cosine squared beta equals 1. That's where this one comes from, and then you're left with this here. And then that's what this becomes here. So it is. It is an equal statement here. It is an identity. In your notebook, students, in example 7, powers of trigonometric functions are rewritten as more complicated sums or products of trigonometric functions. This is a common procedure used in calculus. So when you take your calculus, you'll have this background here that you can use better in that course. So, for example here, examples from calculus, verify each identity. Tan, so A here, tan to the 4th power x equals tan squared x secant squared x minus tan squared x. So tan to the 4th x equals, same thing here, as tan squared x multiplied by tan squared x. Write as separate factors here, this one up here. So we have that. And then tan squared x times secant squared x minus 1. This is a Pythagorean identity over here. So we have tan squared x multiplied by secant squared x minus 1 here. So secant squared x minus 1, tan squared x would be 1 here. So tan squared x multiplied now by secant squared x minus tan squared x. We get that. So that is what this would simplify into here. So tan to the 4th x equals this over here. When you break it down up here, and then you use a Pythagorean identity here, and then you put it back together again, and you end up equaling this over here. So tan 4th x does indeed equal that. So B here would be sine cubed x cosine to the 4th x. Does that equal cosine to the 4th x minus cosine to the 6x sine x? So write as separate factors up here. Sine cubed x cosine to the 4th x equals sine squared x cosine to the 4th x sine x. Write as separate factors here. So this here, sine cubed x, sine squared x times sine x would be sine cubed. We just broke that down. This we're going to keep the same here. And then we have a Pythagorean identity here, don't we? Cosine to the 4th x sine x. Sine squared x is the same thing as 1 minus cosine squared x. Yes, it surely is. So 1 minus cosine squared x, we're getting close to over here. So cosine to the 4th x minus cosine to the 6x sine x. So when you multiply these two together here, this is what we end up here with sine x, and then we have this going on here. This times that is cosine to the 4th x, and then this times that is negative cosine to 6x sine x. So what do we do with that? When we simplify that back, we go into C now. Cosecant to the 4th x cotan x equals cosecant squared x cosecant squared x cotan x, which is this over here. Write as separate factors. So we break this down into that. And then when we break this down further, here cosecant squared x, 1 plus cotan x cotan x. So cosecant x here becomes 1 plus cotan squared x. And then when we multiply this out here, we have cosecant squared x, and then cotan x plus cotan cubed x. So that would become this over here. See, cosecant x, cosecant to the fourth x, cotan x. So cosecant x, multiply that. So here we go into our guided practice here. Powers of trigonometric functions are rewritten to be satisfied. To be useful in calculus, verify the identity. So we have tan to the fifth x equals tan cubed x secant squared x minus tan cubed x. So when we break this down, tan to the fifth x is the same thing as tan cubed x times tan to squared x, right? So tan to the cube x, and then this is an identity here. This is a Pythagorean identity. Secant squared x minus 1. Then we have tan cubed x, secant squared x minus tan to the cube x here, because this is a Pythagorean identity here, negative 1. This times that, tan to the cubed x times negative 1 will be negative tan to the cubed x. And then down here for that one, that's up to you. That is lesson 5.2 part 3. Email me here for questions or course materials. Thank you very much.